Today we're going to talk about polynomial. So we wanted to understand what is polynomial, and then we're going to be able to do add, subtract, multiply, divide by polynomial in this section. The first example we see here, we wanted to write each of the following polynomial in standard form. List all of coefficients, starting with the leading coefficients, and give the degree of the polynomial. So we wanted to find standard form and coefficients, and then degree is what we're trying to do. So this is going to be a polynomial on A, and your standard form is going to be 3x squared plus 0x minus 5. Because if you're looking at what is given, you start with square and you do not have first exponents. So you're going to use the 0 for the placeholder and then constant. Your polynomial is when your exponent is the natural number. When exponent is natural number, then your given expression is going to be polynomial expressions. So once you write it in a standard form, then we can find the coefficients. Your coefficient is going to be all those numbers in front of the variable, or just number itself, right? So you could say 3 is your leading coefficient because the one with the highest exponents term will give you the leading coefficients. Second coefficient is 0. And then the third coefficient is negative 5. Or you could also call negative 5 as the constant without the variable, right? The degree of these functions is going to be the second degree. Okay, so then if we're looking at the next one, standard form always start with the highest exponents, and you see the square will be the highest, then first, and then constant. So it will be x squared minus 2x plus 8 will be the standard form. And your leading coefficients, if you don't see any number, it means you have 1, right? So 1 will be leading coefficients. Negative 2 is the second coefficient. Third coefficient is 8, and 8 is also constant. This one, your degree is 2 also. This one, what it's given is the polynomial. This is a polynomial, right? In a standard form. And if you wanted to find the coefficient, that's going to be 2 and negative 1. So 2 and negative 1. The degree on this case, if you have different variable what the exponents is multiplied, then you're going to add your exponents. And that's going to be your degree. This one, you only had one variable, right? So the highest exponent of that variable will be the degree, but this one have x variable, y variable, and that they are multiplied to each other. So then you're going to add these two numbers to have a degree. And this one will give you 5th degree. Zero itself is also polynomial, and your coefficient is going to be 0, and because it's 0, there is no degree. What about example 2? It says evaluate polynomial for x equals to 1 and x equals to negative 2. What does evaluate means, right? Evaluate means find this polynomial value when x is equals to 1. It means you're going to substitute your x with 1. Everywhere you see x, it will become 1. So then you get 3 times 1 squared minus 4 times 1 plus 6. And then you do order of operation once you replace x with number. So that will be, do the exponent. 1 squared is 1 times 3 is 3 minus 4 plus 6. This gives you 5. So if it's a positive number, it's not really bad. But then if it's negative, you need to be careful with that negative sign. So when you do the square negative number, that becomes positive. Negative 4 times negative 2, make sure that becomes positive 8. And when you multiply, that's what you left. And then when you add them up, 12 plus 8 is 20, plus 6 is 26. So this is what evaluate means. The next example, they're asking you to perform the indicate operations. So we're going to start looking at adding and subtracting. Adding is one of the easier one because you just need to remember you can add the like terms. So they say 3x squared plus 2x plus 5 and 2x squared minus 3x minus 2, add them up. So only way that you can add these two is when you put the like terms together. So you're adding them. So the like term means that the one with the x squared will x squared and x squared. That will be the like term where you can combine the leading coefficients. One with the x and x, you can combine the leading coefficients. This is constant, right? Then you can combine those two together. So that it gives you 5x squared. That will be negative 1x plus 7, right? Always the like term, adding, subtracting. So addition, subtraction is not too bad. So this one, we wanted to open the parenthesis first so that you can combine the like term. If you have a grouping notation, you cannot combine the like term. So open the parenthesis. One term multiplied by 3 terms, you need to distribute this one to all 3, right? So then you get 2x squared minus 2x plus 2. And when you distribute 3 to these 3 terms, I wanted to put it all together, stuck up with the same term. So it will be 6x squared plus 3x minus 18. And you're adding, right? You end up getting 8x squared. Your term will stay same. It's just that your coefficient is going to get added. Right? So that's what you're going to get when you're adding those two. What about your subtracting? Well, same thing. Just remember or be careful when you have a subtraction. This subtraction will get distributed into follow parentheses, which will change your sign. All 3 terms will change sign. So then I will have 3x squared plus 2x plus 5, and when you distribute negative, you end up getting negative 2x squared plus 3x and minus 2. And when you combine, you get positive 1x squared plus 5x and plus 3 is what you have remained. So just remember to change the sign. Let me make sure you're distributing this 3 times. So this becomes negative, positive, negative, right? Let's try one more. This one is distributing to open the parenthesis first. So you get negative 6x squared plus 18x plus 3. Now you're distributing negative 2. So it'll be negative 8x squared And negative 2 times x is going to be negative 2x. When you combine, you get negative 14x squared plus 16x plus 3. So that's what we do with the addition subtractions. Now we're going to look at multiplications. Multiplications, using some of those rules we went over, right? So if we have 2x squared times 6x cubed, then we will do multiplying 2 times 6, right? 2 times 6. This is all multiplication, even the one that you don't see, right? This is all multiplications. And multiplication is okay to switch the order. So you will multiply 2 times 6 because it's easier, number by number, right? Which will give you 12. And then you have x squared times x cubed. And this is the part where we did it previous sections. Multiplication of exponent with same base, different exponents. You add the exponents, right? So it will be 12 times x to the 5th exponent. So do the same thing on this one. 2x squared times 6x cubed plus 3. Make sure you're multiplying this first, that, so it's nice to put parentheses if you have more than one term. That way that you know that you need to distribute, right? You need to distribute when you're multiplying. So you will get 2x squared times 6x cubed. 2 times 6. X squared times x cubed is 5th, right? Now 2 times 3 and then x squared, right? Again, where we get that number from? This number comes from 2x squared times 6x cubed. And this comes from 2x squared times 3, right? So that will be what we should get. What about if you have more than one terms, right? Here, if you had more than one term, one was more than one term, then you distribute this, right? So if both of them is more than one term, you need to do by individual. So trying to distribute 2x to this trinomial. Once you're done with 2x distributing into these 3 terms, then 5 distribute into these 3 terms, right? So that's what I will do. I will do 2x times x squared will be 2x cubed. And then 2x times negative x will be negative 2x squared. And then 2x times 2 will be 4x. And then now I'm going to do 5 times x squared. And then 5 times negative x will be negative 5x. And then 5 times 2 will give you plus 10. Once you're done distributing all, then you're going to come back and combine the like term. You only have 1 cube, but then you have 2 square, gives you positive 3x squared. And then you have 2x by itself, and then plus 10. And you do not have any other like terms to combine, so that must be it for that problems. What about if we have 2 terms multiplied by 2 terms? So we do the same thing. So first you're going to multiply 3x into these 2 terms. Once you're done with that, then negative 8 into these 2 terms, right? So if we write that down, I will do Let me write it a little bit under so I will give you all the writing. So I will do 3 times x. And I did that first, right? And then I will do 3x times 2. Then, because I'm done with 3x now, I will do negative 8 times x. And then the last one will be negative 8 times 2. Once you're done distributing, now you do combining the like term. Look like this is the like term. Gives you negative 2x minus 16. I put number here. That's the first multiplication, second multiplications, third and fourth. The easy way to remember this is using FOIL. FOIL. We say FOIL because we're doing first 2 multiplications, outer multiplications, 2 outside, inner, 2 inside, last 2 multiplications. So you can remember this order as foiling method. Then you will get first 2 multiplication, 2x times 5x, 10x squared, plus 2x is outer. Inner will be 15x, last 2 will be plus 3. Combine the like term, you get 10x squared plus 17x plus 3. Let's try one more time with this. So it will be x times x times negative b, 8 times x, and then positive 8 times negative b. And look like you don't have like terms to combine, so that must be it. This one right here, we do foiling method again. So x times x times 2x, negative 2 times x, and then negative 2 times positive 2. Combine the like term, look like they cancel out each other. And you will see if you start doing more problems that if you have exactly same number, but then opposite sign between, then you end up canceling the middle term because middle term will come up with the opposite sign, right? But you will able to figure that out if you do plenty of exercise. So this one will be the same thing. I end up getting x squared. See, you have a same term, x and a, but one is positive, one is negative in between. So this one, it will cancel out the middle term because one will be negative 8x, the other one will be positive 8x minus a squared. So this will cancel out the middle term. And it gives you x squared minus a squared. This one, don't forget this is one of the property that you cannot distribute exponents. So instead of distributing, you need to understand this is same as multiplying base twice. And when you do FOIL, you end up getting x squared plus 2x plus 2x plus 4. Combine the like term, become plus 4x plus 4. Right? Same thing with this one. So this one will be the same as if you FOIL 2x minus 1 times 2x minus 1. right? What about this one? This one means same as x plus 2 times x plus 2 times x plus 2. So x plus 2 cubed means you're multiplying x plus 2, the base, 3 times, because you cannot distribute exponents when you have additions or subtractions. So make sure to multiplying whole thing fully, right? Whatever that's going to be. If I'm trying to finish this problem, I will have foiling this again. So it will be 4x squared minus 2x minus 2x plus 1. Combine the like term, I get 4x squared minus 4x plus 1. This one, if I FOIL those two first, I will get x squared plus 4x plus 4 times x plus 2. And when you multiply that, you get x cubed plus 4x squared plus 4x. Then you get plus 2x squared plus 8x plus 8. And when you combine this with the like term, you get x cubed plus 6x squared plus 12x plus 8. Now we're going to look at dividing. So when we're dividing polynomial, we have two different methods of doing dividing polynomial. The first method is when denominator, you're dividing with only one terms like this. So this A, B, C will have same types, but if you have more than one term on denominator like this one, this 3, you're going to use the long divisions, right? So two different ways. So first 3, we will do it as just the regular fractions of reducing. So this is multiplication. We should be able to separate out, right? This is having an x to the 6 exponents, and this is having x to the square. And then we can look at it as number itself. We know that 3 goes into 18 6 times, right? With this 2, you could do x to the 6 exponents minus 2, right? So what do you get? You end up getting 6 left over from the numerator, and x to the 4th exponents get left over from the numerator, and denominator have 1, which you do not really need to put over 1 down, right? If you don't have any other number than 1. If you have more terms on the numerator than this, the first one, right? This one had 1 term. This one had 3. Then all you need to do is separate into 3 different fractions and then reduce them, right? So you will do 5x to the 5th over 5x cubed plus 3x to the 4th over 5x cubed plus 10x over 5x cubed. So think as you have a separate fractions. So this 5 and 5 cancels out. It will be minus 3. So you will end up getting 2, right? So you have x squared remaining from the first fractions. Second fraction look like I have 3 over 5 will stay because there is no commons. And when you do 4 minus 3, you get only x remains. And then you have 5 goes into 10 twice. And maybe you will do subtracting 1 on denominator, right? So then you get plus 2 on the numerator and x squared on denominator. If that was a little confusing, let's do one more, right? So what do? We separate them. Because you have 3 terms on the numerator, 1, 2, 3, you will have 3 fractions. And then at the same time, when you're rewriting it, you want it to combine the signs so you don't get confused with too many signs. So the second one, you're going to look at second fractions, you're going to look at the positive on the numerator and negative on denominator. So that gives you subtractions. And then the third one, you have negative and negative, right? So that will make it positive. So 2 goes into 8 and subtract 2, right? So you end up getting negative 4x squared. And then you get 2 and 2 cancels out, and x squared cancels out x squared. That will be just minus 1. And this one, have nothing to cancel out, will be 1 over 2x squared. The next one, when you're looking at the next one, because you have 2 terms on denominator compared to the other first one, you're going to do long divisions, right? What was a long divisions? Just remember, long division with number is like you're doing 20, let me write it. 251 divided by, let's say, 2. 2 goes into 2 1 times, and we do subtractions, right? When you don't have any remainder, bring down, or that remainder is small enough, bring down the next number. 2 goes into 5 twice, gives you 4. Subtract, bring down the next number. 2 goes into 11 5 times, make it 10. Subtract, right? You're subtracting all the time. That will give you 1 as the remainder, right? So that's what we call long divisions. So we will do the same thing for these problems. Rewrite this into the long divisions. And your rules on the long divisions, make sure it's descending order. So start from the highest exponents. And if we have any missing term, you're going to write 0 for the placeholder. This problem right here do not have that. So start with square first and constant, right? Linear and constant. So there is no missing value in between. So write it in a long divisions. And what you need to think is, what do you need to do for x to completely get rid of 3x squared? So if you look at it, 1 times 2 give you 2 because you're subtracting. Long as you have the same number, it will cancel out. So how do I make 3x squared from x? You're going to multiply 3x, right? So then you're going to write that down on top of the same term. So you're going to write 3x. And once you decide what to multiply to get exact same of the first term, then you're going to multiply this number to the whole thing. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. And then what else you do? You subtract. So you subtract this. That will change this sign into additions, right? And then when you subtract, what do you end up getting? Well, these 2 cancel out. This will be negative 7 plus 6 will be negative x, 1x, right? You need to bring down the next digits because you have to have two term to be able to subtract. So when you bring down plus 5, now you're repeating what I just did. What do you need to multiply this x to become negative 1x? Well, look like negative 1, right? So you're going to multiply by negative 1. Once you decide what to multiply that to the whole thing. So negative 1 times x, negative 1 times negative 2. That will give you negative 1x plus 2. And don't forget you're subtracting. When you subtract, negative become positive, positive become negative, right? This cancel out. Gives you 5 minus 2, so that will be 3. So your remainder is 3. And the way that you're going to write that down to the solutions, you could say 3x minus 1, but for the remainder, you wanted to add your remainder plus 3 over x minus 2. Why is it x minus 2? 2, not just 3, because 3 didn't get to divide it with x minus 2 yet, right? So remainder over what you are supposed to dividing with, right? So that's how you're going to use the long divisions. And long division only happen when you have more than one term on denominator, right? Not on this one. So then let's do a few more. Oh, yeah, a few more. Let's try this one. Remember, long divisions, you're going to write descending order. So start with the highest exponents, cube, square, linear, constant, right? That's the order. So I will have 3x cubed plus 4x squared plus x plus 7. And then the denominator, you start with square, quadratic, but then you don't have linear. You don't have x to the first exponents. That's what we're saying is missing terms. That missing term, you're going to write it with 0. So it will be x squared plus 0x plus 1. And then we wanted to think, what do you need to multiply x squared to become 3x cubed, right? Because we wanted to have exactly same thing, so when we subtract, it will cancel out each other, right? That will be 3x. So I will put on top of x, 3x. 3x times x squared. I get 3x cubed. 3 times 0 is 3. And 0. And we will say positive 0, since we don't have negative 0, right? And x squared, 1 times 3x will be plus 3x. Now we're subtracting, right? Subtract, so this become negative, this become negative, right? So this 2 cancel out, and you get 4 minus 0 is 4. 1 minus 3 is negative 2. And because we have 3 terms right here, 1, 2, 3, you need to have one more terms. So I will bring this down. Makes it plus 7. Now I'm repeating what I just did. So what number do I need to multiply x squared to become 4x squared? That's going to be plus 4. And when you multiply that, 4 times x squared, 4x squared. 4 times 0x, 0x. 4 times 1, 4. But we're subtracting, right? Subtracting, sign change, right? So this 2 cancel out. This gives you negative 2 minus 0 is negative 2. 7 minus 3 is plus 3. So your remainder is plus negative 2x plus 3 over your denominator. And that will be the solution. Right. Okay, let's try one more. So don't forget, long divisions. In order to use long divisions, you have to have more than one terms on denominator. If you have a missing term, use a 0 for the placeholder. Look like my video got disconnected, so let's restart this problem. Remember, in order to use the long divisions, you need to have two terms on denominator. And if you have any missing term, you're going to use 0 for placeholder and write it in a descending order for the long divisions. So you will have look like x cubed plus 0x squared plus 0x minus 27. All the missing term like square and x to the first exponent is not there. So make sure you use it 0 for the placeholder, dividing by x minus 3. And in order to make x cubed, you're going to multiply x squared. Now you're going to multiply x squared to the x minus 3. You will get x cubed minus 3x squared. You're doing a subtraction now, so sign will change. And then you get no more x cubed. You will get positive 3x squared. Bring down the next digit will be plus 0x. And this x to become 3x squared, you're going to multiply by positive 3x. Positive 3x multiplied by x. Multiply by x minus 3, you get 3x squared minus 9x. And when we subtract, that cancels out. This becomes positive. So you end up getting 9x remaining. Bring down the last digit. Now you wanted to make this x 9x. So you're going to add or multiply by 9. You end up getting positive 9x minus 27. When you subtract those two lines, cancel out, you get 0. So you have 0 remainder. So your solution will be x squared plus 3x plus 9. Okay, so this long divisions, I also wanted to show you there is another way of doing this, so-called synthetic divisions, right? How do we use the synthetic division? Synthetic divisions, you only use the number instead of variable. So for some people, it's easier. So I'm going to use the synthetic divisions with this problem and show you will get exactly same number. So synthetic divisions, you're going to write only number down. So from 3x squared minus 7x plus 5, you're going to just use 3, negative 7, positive 5. So you're going to have 3, negative 7, positive 5. You're dividing this with x minus 2. If x minus 2, you're going to use positive 2. So opposite of the sign from the number, right? So just the positive 2. If it's x minus 2, it will be positive 2. If it's x plus 2, then it will be negative 2 that you're dividing. First number always bring down straight. And this 2 number is the one that you're going to multiply. You multiply this 2 number and write it in between. And you add those 2 number. So bring down the first digit so you have something to multiply. 2 times 3 is 6. And you add this 2 number. When you add this 2, you write it here, will be -1. And then again, this 2 is what you're going to multiply to write it here. So 2 times -1 is -2. And add this to a number will give you +3. This means because you started with square, right? You started with square and you divide it with 1x, right? So this is going to become linear. Quadratic divide with linear, you end up getting linear. So you have 3, right? So it'll be 3x minus 1 with remainder of 3 is what you're going to get. Which is going to be the same as what we have it here, right? This is going to be identical once you're done. Because remainder, you can write it as x minus 2 on denominator. Same thing with this problem. That's what I wanted to show. So if we wanted to use the long divisions, we only use the number, right? So from cube will be 1. Square, there is no square, so 0. Linear, that will be 0. Constant, -27. Dividing this with x minus 3, so it will be +3 that you're going to use. Bring down the first number. So you have something to multiply. You do 3 times 1, that will be 3. Then you do 0 plus 3 will be 3. Now you do 3 times 3 is 9. Add these 2 number, you get 9. 3 times 9, 27. Add this 2 number, you get 0. This means you have remainder 0. Where you had remainder 0 in long division also. You started with cube, right? You started with a cube. So starting cube with dividing by linear, so you have a quadratic square remaining. So it'll be 1x squared plus 3x plus 9 with no remainder. And that's what you had it right there, right? This is the same solutions. So we call this is synthetic divisions method, and this is long division method. Two different way of solving the same problems.